Okay, so the first thing that I want to go over today is going to be points, lines, and planes. We have not seen this notation in quite a while, and so I wanted to make sure that we remembered how to do those. So looking at number 1, we have a line over AB. Do you think that represents a point, line, or plane? A line. And not only a line, but since it doesn't have arrows, what is it? A line segment. I know that's not a choice, but it is a line segment. What about number 2, this odd shape right here? What does this represent? A plane. Okay. And then what about a uppercase capital letter? Okay, a point. What about if that uppercase letter is cursive? A plane. Very good. Again, we have an uppercase letter. Not a plane because it's not cursive. So it is a point. Okay, and then what about lowercase cursive? A line. So if it's uppercase in cursive, it's a plane. If it's lowercase in cursive, it's a line. The way that I remember that is uppercase letters are bigger, right? Okay. And lowercase letters are littler. Now, is a plane or a line bigger? A plane. It covers more. It's a whole surface area. So the plane goes with the uppercase because it's big, and a line goes with the lowercase because it's smaller. Does that make sense? That is how I keep those straight. Now, how many of you remember what coplanar means? What is it? Very good. On the same plane. Okay, so we're looking to see, is A, B, and D on the same plane? So here, here, and here. Are these on the same plane? Yes, they're all on the front of this cube, which means it's all on the front plane. So this would be yes. Okay, and now what was the definition of collinear? On the same line. Okay, so we're looking to see if C, G, and H, are those on the same line? No. Perfect. Okay, let's talk about the formulas that we want to know for this portion. Okay, the first one we look at is segment addition postulate. You will know it's segment addition postulate because you will find the word between in the problem. Who remembers the formula for segment addition postulate? Very good. Part plus part equals the whole. Okay, and then what about midpoint? What does midpoint do? It divides the segment into two what? Okay, congruent or equal, whichever one you want to use. Congruent or equal segments. So if my two parts are equal, what formulas could we use for that? Part equals part, and 2 times part equals the whole. Now, if it is a midpoint problem, you will see the word midpoint in the question. And the last thing we talked about with segments were segment bisectors, which means it divides it into two what? Congruent or equal parts, okay? So if those two parts are equal, then what two equations also apply here? Part equals part, and 2 times part equals the whole. Perfect, okay? And if it's a bisector, then you will see the word bisects in the equation, okay? So let's use those three to solve a few and make sure we remember how to set these up. So the first one I want to look at is number 16, which is on your second page. So flip and look at 16. So 16 says if J is the midpoint of KG. So the first thing I want to note is that it's a midpoint problem. What does midpoint mean? It means what? So what does that mean about the two segments if it's in the middle of the line? So we have 2 equal parts for midpoint, okay? Now, you may have not believed me before on your test, but it is very, very important that you draw your line. So the first thing that I want to do is draw my line, and I'm going to label it so I can see if I'm given parts or wholes. So I have line KG. And J is the midpoint. Then it tells me that K to G, so from this endpoint to this endpoint, is x squared. And then it tells me JG, from here to here, is x plus 4. Okay? So is JG a part or a whole? A part. What about KG? The whole. Okay, so there's only 2 formulas that work for midpoint. It's either part equals part or 2 times part equals whole. So which one would we have to use here if we only have one part and a whole? 2 times part equals whole. So we're doing 2 times the part equals the whole. So our part is x plus 4. And that equals our whole, which is x squared, okay? So we are going to take this 2 right here, and I'm going to distribute it to both things in the parentheses. So that's going to give me 2x plus 8 equals x squared. Okay, something should be signaling in your head that this is special. What is it? Okay, what does x squared mean? That you have to factor. So in order to factor, what do we have to do? Move everything on one side. So am I going to move 2x and 8 to the right, or am I going to move x squared to the left? Okay, why would I move both 2x plus 8 to the right instead of moving x squared? Walker? Very good. We do not want a negative x squared, so I'm going to move this to this side, and I'm going to move this to this side. So when I move, I'm going to rewrite it up here, x squared. If I move 2x to the other side, what does it become? Okay, minus 2x. And what about 8? Minus 8. Okay, and now it's equal to 0, and now everything's on the same side, and we can factor. What type of factoring is this? Trinomial shortcut. So we can go ahead and draw our parentheses. What letter is going to go in both of these? X. Okay? And I'm looking for something that multiplies to give me negative 8 and adds to give me negative 2. Negative 4, positive 2. Okay? Negative 4, positive 2. All right, so what does that mean this x would equal if we solved? 4. And this one would be negative 2. So it's always the opposite. Now, are we finished with our problem? Why not? Okay, they ask us for KJ. Now, they ask us for this piece, but we're not given it. How are we supposed to find it if they didn't give me a piece? Okay, why? Okay, so we know that KJ and JG are equal because if this is the midpoint, it's split into 2 equal parts. So since kj is equal to jg, we can just plug in for jg, which is x plus 4. So if I plug in a positive 4 here, what would it give me for kj? 8. If I plug in a negative 2 here, what would it give me for kj? 2. Okay, questions there? Are y'all remembering this? Yes. Okay, let's look at 17 next. So here, the very first thing that I want to do is go ahead and draw my line so I can label it and figure out if I have parts or wholes. So it tells me E is between M and G. So M and G are my endpoints. And E is somewhere in between. It tells me ME is 2/3 x. It tells me MG, so from endpoint to endpoint, this is 8. And then EG is 4. Now, if it's between, what formula goes with between? Part plus part equals whole. Even if you didn't know that, what are we given? A part, and a whole. There is only one formula that uses a part, and a whole, and it's part plus part equals whole. So we're going to set this up as 2/3 x plus 4 equals our whole, which is 8. So part plus part equals whole. Now, we want to get x by itself. So what would we do first? Okay, we would subtract 4. Why would we not mess with the fraction first? Okay, 2/3 is connected to x. We're worried about everything else that is not connected to it first, and then we'll deal with this. So we're going to bring down 2/3 x. 8 minus 4 is 4. Okay, then how do we get rid of fractions? You multiply both sides by the denominator. So we're going to multiply both sides by 3. On my left-hand side, the 3's go away, and I'm left with 2x equals 12. Okay, then how do we get x by itself? Divide by 2, and x equals 6. All right, what does it ask me to find here? ME. So we're going to take this and plug it back into ME. ME and EG are not supposed to be equal necessarily because it's not a midpoint or bisector. But someone did point out in the other class, we don't have to plug 6 back in because we know the whole is 8. We know this part is 4, so what is left for this part to be? 4. So ME is actually equal in this instance, but it won't always be if it's just a between problem. Okay. Next one I want to look at is number 18. So in number 18, we're using the figure to the right. It tells me TW bisects UY. So what does bisects mean again? Okay, it cuts in half. So remember, we talked about what's being cut versus what's doing the cutting. Okay? So I want to know, is TW the knife or is UW the knife? Which one's doing the cutting? TW. So this is my knife, and UY is what is being cut in half. I'm going to say it's my food. Okay? So we're going to split our food. So TW is taking uy and it's cutting it into 2 equal parts. So I'm going to label that as equal, and I'm also going to put up here ux equals xy, just so I don't forget. Now I'm going to label, and so it tells me that ux, this part right here, is 3x, and then it tells me uy, this entire length right here, is x squared plus 4x minus 3. Okay? So is 3x a part or a whole? A part. Is x squared plus 4x minus 3 a part or a whole? It's a whole. So what is the only formula that uses one part and one whole? 2 times the part equals the whole. So we're going to do 2 times 3x equals x squared plus 4x minus 3. So the first thing that I want to do is multiply 2 times 3x, which gives me 6x. We're going to bring down x squared plus 4x minus 3. Okay, what should be going off in your head? There should be signals going off. Okay, we have an x squared, which means we have to factor. So what are we moving here? So I'm going to subtract 6x from both sides, and that's going to give me x squared minus 2x minus 3. Okay, so what type of factoring is this? Trinomial shortcut. So go ahead and put your parentheses. What letter's going in the front of both? X. And then what multiplies to give us a negative 3 and adds, and adds to give us a negative 2. Negative 3 and 1. Does that work? Okay. So we're going to do negative 3, positive 1. So what should my x's equal? 3 and negative 1. Okay. And then what did they ask us to find? They asked me to find xy. Now, I'm not given that piece, so how am I supposed to do that? Okay, we found up here that ux equals xy. So if xy is equal to ux and ux equals 3x, we're just going to take these x's and plug in. So if I plug in 3, that's going to give me 9. If I plug in negative 1, I get a negative 3. Can we have a negative distance? No. So my answer for ux would be, for xy would be 9. Okay, do we have any more questions on how to plug in for segments? Yes. We can come back to that one. Yes, ma'am. Okay, now I want to talk about angles. Okay, so who can tell me what the vertex for angle 2 is here? So angle 2. Yes, it is B. Okay, our vertex is always going to be a point. Do y'all remember what a side is made up of? Anybody? Not lines, but they're actually rays. Okay? So if it's a ray, then it has to be written a certain way. So can somebody tell me what one of the rays of angle 1 would be? BA. And the other one would be BD. You always, and I was worried y'all wouldn't remember this, you always start from the end point and go out in the direction of the arrow, because where the arrow is going, it keeps going forever. Same here, we'd start at B and go out to D. Okay. Would y'all like to look at 27 or 28? Okay, let's look at 28. So for 28, we are given that ABC, this entire measure right here, is 162. They want me to find ABE and then EBC. How would I find ABE, which is, and I'll highlight because it's been a while since we've done angles. If I'm looking for ABE, I'm going to start at A, I'm going to color down to B, and then I'm going to go out to E, and the angle I'm looking at is where these two connect. So I'm looking at this entire angle. I would add the two numbers. So that is a 65 and a 45. When you add those together, you get 110. So this one would be 110. So this whole thing right here is 110. Now, how would I find what's left over right here? Very good. We'd take 162. We'd subtract this to find what is left over for this. So we'd subtract 110, which would give us 52 degrees. Okay? Now, on 27, all you're looking at is there's either vertical angles or it's a linear pair. Okay? Vertical angles are what? Equal. They're across from each other or opposite of each other, and they're equal. Linear pair are what? On the same line, and they add to 180. Okay? If we need to come back to that one, we will. Okay, now I want to talk about how to identify whether the angles are vertical, complementary, supplementary, adjacent, or bisector. So let's start with 29 first. So in 29, we're looking at this angle right here on the left and this angle right here on the right. What type of angles are those? Vertical. And we know vertical angles are equal. So what will we do with these two measures? Yep, set them equal. 7x plus 10 equals 2x plus 45. Then it's just a simple solve for x. So we want our x's on the left, numbers on the right. We would subtract 2x from both sides. That would give us 5x plus 10 equals 45. And then we would want to move this 10 to the other side. That would give us 5x equals 35. And finally, we would divide by 5, and what would x equal? 7. Now, they also want us to find ABC. So ABC, I'm going to go ahead and highlight it so I can see it. A starts here, then I go to B, then I go to C. So I'm looking at this angle right here, which is 2x plus 45. So I'm going to take 7 and plug it back in. So 2 times 7 plus 45. What would that give us? 59 degrees. Okay, I'm not going to go through and solve every single one for us, but I do want to talk through how we set them up to make sure we know how to identify them. So in number 30, if I'm looking for this angle right here and this angle right here, what type angles are these? They are supplementary, which is the same thing as a linear pair, which means they do what? They add to 180. So how would we set up this equation to solve? 4x plus 4x plus 20 should equal 180. Very good. Okay, so I'm not going to solve that one because I know y'all can solve those. What about 31? What type angles are those? Complementary, which means they do what? Add to 90. So how would we set that one up to solve? 50 minus 3x plus 8x plus 5 equals 90. Perfect. Now, there is a typo on 32. Okay? This first one, actually there's not a typo. It just tells us BA bisects DBC. So if BA bisects DBC, what does that mean about this angle and this angle? They're equal. So angle 1 is equal to angle 2. Okay? It tells me angle 1 is 4x minus 5. And then it tells me DBC, this whole angle, is 16x minus 34. Okay, so I have a part and a whole. What am I going to be able to do if I have a part and a whole? 2 times part equals whole. So we do 2 times 4x minus 5 equals 16x minus 34. Okay. Are there any questions on those? Okay.
I have a question in general. Not for this. How many questions is the thing?
I will let you know after. Okay. And I have one more that I want to show you, and then we can go back if we need to other ones. So it's been a while since we've done the word problems like this. So we're going to look at 38. It says the measure of the complement of an angle is 66 more than twice the measure of the angle. Find the measures of the angles. Okay? So how many angles are we going to have to add together to get a complement? 2. We're going to have one angle plus the second angle, and that's going to equal, what is the complement? 90. Okay? So it tells me that one of those angles, so we're going to say angle 1, is 66 more than twice the measure of the other angle. Do we know the other angle? No. So since we don't know angle measure 2, what can we let it be? X. And then if this is 66 more than twice x, how would you write that? 2x plus 66. Okay? Now, to solve, to find both angles, we would have to do our first angle plus our second angle equals 90. So we do 2x plus 66 plus x equals 90. We combine our like terms. So 2x and x give me 3x plus 66 equals 90. We would also subtract 66. That would give me 3x equals 24. To find x, we would divide both sides by 3. And x would equal 8. So one of my angles is 8 degrees. How would I find the other? You can plug it into this equation, or what else could you do? Subtract it from 90, because we know it adds to 90. So 90 minus 8 is 82 degrees. So my other one would be 82 degrees.